So let's talk about Booleans. Booleans are a primitive data type that can hold two possible values: true or false. No quotation marks, no numeric type, nothing with numbers, just true or false. And Booleans are things that we use to make decisions in Java, which is to say that every decision that we make in Java is going to have a true or false component. It's going to be a binary. It's going to be a split. And so we get those from Booleans, or from the things that produce Booleans. Usually with the decisions in Java, we have, like, if some condition is true, we do one thing, and if that condition is false, we do another thing. Or sometimes we have a lot of conditions that we chain together, and we'll learn more about that next week. So we get Booleans, we can hard code them, or we get them from the relational and equality operators, which right now we're only going to talk about regarding math. And so we can use these 6 operators to derive Boolean values using math, using the numeric types. And there are other ways that we can do it too. We'll talk about those in about a month and a half. So to test to see if 2 values are equal, we use the double equals sign. The single equal sign is for assignment. The double equals sign is for comparison. We can think of it sort of like a mirror, right? So we've got a mirror just coming right down between these, held in place by these equal signs. If the thing on the left is the same as the thing on the right, it all resolves to be true. If the thing on the left is different than the thing on the right, it all resolves to be false. Let's take a look at that in the wild. So go vim boolean demo.java, public class boolean demo. And we're not going to import a scanner at all. We're not going to worry about that. Though you can certainly if you want to. Public static void main string args, and then from this, right? So we're actually, we may as well import a scanner. Okay, I'll make a scanner, which I'm going to call sc is equal to new scanner system.in. We'll print out a quick title banner. Booleans are named after the mathematician George Boole, and so they're relatively recent inventions. All right, so we're going to get a number. System out dot print. Make a new line. Give me a number. And we'll catch that number using the scanner's .nextInt method. And then we'll go system dot print. Make another new line. Is your number a 7? Okay, so that's the thing that we're going to check. And then with Booleans, we typically, the convention for naming them is to use an is or a has start. So the convention here will go is 7, to which we assign the value of user num is equal to 7. And so in this case, this equals right here is an assignment. That's what this one does. This one is a comparison. It checks the thing on the left, sees if it's the same as the thing on the right. Okay? And so which means that if this whole thing is true, that is to say if the number that we give it is 7, then is 7 will be true. If we give it a number that isn't a 7, is 7 will be false. And here's the really fun part. We can print that out. Just like we do anything else. So we're here. We don't have this as we don't have this in quotation marks at all, which means that whatever value is in here is going to be printed out, as is. This will be our chance to see some Booleans in action. It'll be pretty exciting. So we're going to, using the scanner, collect. So you're going to create a scanner, use the scanner to create a number, and then figure out if that number is a 7, and print out the results. So it should be pretty straightforward. This will be a fast demonstration of Booleans. Javac boolean demo.java compiles just fine. Then we can run it. Let's give it a number. So let's give it a 7 first and see what happens. Is your number a 7? True. Now this is our Boolean value right here, that true. Let's try it again. Let's give it a 15, which is very definitely not a 7. And so is our number a 7? False. That's again, this is our Boolean value. We're printing it straight to the screen. We can try it again, say with a multiple of 7, or maybe a negative 7. And we know also negative 7 is not a 7. So that's false. What the Java virtual machine does is on the fly, it figures out exactly what's happening. That's with the double equal sign. We're going to get back into this, and then here in just a second we'll learn. By here in just a second, I mean right now we're going to learn a few more. Okay, so if you want to see if they're equal, we use the double equal sign. Alternatively, if you want to make sure that they're not equal, we use the not equals sign, which is this exclamation point equals. The exclamation point is a negation operator. It just flips the value of certain Booleans. And so something like 18 is not equal to 73, that would be true, since 18 and 73 aren't equal. And we can add that in too. Let's add that into our, let's add that in as well. System.out.print, make a new line. Is your number not 7? And then Boolean is not 7 is equal to usernum exclamation point equals, sometimes called bang equals, 7. System.out.println is not 7. Okay, so we're good here. Okay, so right up top, we check to see if our number is a 7. Then we check to see if our number is not a 7. And we may as well, if we're feeling generous, use some comments to organize our thoughts. Check to see if not 7 using inequality. These comments are a little bit obvious, but that's okay. Check to see if 7 using double equals. Comments are a little bit obvious, but that's okay. It's not a bad thing right now that they're a little bit obvious. Okay, so we're going to check to see if our number is a 7. Then we're checking to see if it's not 7. And we'll roll from there. We'll compile. And we have a misspelling. See, right here, that we can't find this println because I misspelled it. That should be a println. That's easy enough to fix though. Just go back, fix that right off. Compile. Everything runs just the way it should. Java Boolean demo. Okay, so we're going to give it a number. We'll give it a 7 first. And so is our number a 7? That's true, because we gave it a 7. Is our number not 7? That's false. Okay, let's try it again, but with a different set of values here. Or with a different value, I should say. We'll run it again. Let's give it a 687. Our number, in this case, is not a 7, so the is it a 7 is false. Then the not 7 should be true. These are Booleans. There are a few more operators, and these ones are going to look really familiar to you if you've taken math beyond Algebra 1, which you have. There's the greater than and less than sign, which work exactly like they do in regular arithmetic. They work exactly like they do, which is to say if the number on the left is greater than the number on the right, and we're using a greater than sign, we make it false. If the number on the left is less than the number on the right, and we're using a less than sign, we make that true. And so it all works out pretty much exactly like you'd expect. Same thing happens with the greater than or equal to and less than or equal to operators. Those also work pretty much exactly like you'd expect. We make the greater than or equal to with the a right-facing angle bracket followed by an exclamation point. We make the less than or equal to with a left-facing angle bracket followed by an exclamation point. Rather than fancy greater than sign with a line under it, or a less than sign with a line under it. And so with the relational operators, let's put these into play real fast. Let's put some of these guys into play. Okay, so we've got the greater than 7, or we have the is it 7, is it not 7. Now let's check to see if greater than 7. Then system.out.print is your number greater than 7. Boolean is greater than is equal to user num greater than 7. System.out.print line, we're spelling it right this time, is greater than. Then we'll check to see if less than 7. I guess we only need one if here. System.out.print, make a new line, is your number less than 7. Boolean is less than is equal to user num less than 7. And again, like this bit right here, and that part right here, and this part right here, and that part right there, since we're using the equality operators and then the relational operators, are all going to end up yielding a true or false. System.out.println is less than. And then we'll see what happens from here. So this should end up being somewhat instructive. Java C, Boolean demo. Let's say we've saved and quit. Now compile. Everything's good. Java, Boolean demo. So if you give it a number, like say 7, our number is a 7. It is not 7. It's neither greater than 7 nor is it less than 7. Okay, and we know that all that's true. That's how these operators work. Let's try it again, and we'll give it a 35, which is not a 7, but it is greater than 7. And so we say, okay, so is it 7 false? That's what it should be. Is it not 7 true? Also what it should be. Is it greater than 7? True. That's what it should be. And 35 is not less than 7, so we should get a false, which is exactly like it should be. We'll try it again, just with a number smaller than 7 in this case. Like say a negative 7,262, which is not a 7. Again, it's not a 7. Is not greater than 7, but is less than 7. So everything works about the way that it should so far. We can try this again with the with the greater than or equal to and less than or equal to operators, but at this point they work exactly like you'd expect. And so when we come back, the thing that we're going to look at is operator precedence and expressions that are a little bit more complicated than what we've seen so far. What we've seen so far is not particularly complicated and isn't yet particularly useful. When we combine it with the mathematical operators, we can start doing some pretty sophisticated things. So I'll see you back here in just a minute.